Right, folks, this is section 9.1, elements of a hypothesis test. What I want to do with just this one video is just intro the idea, basically just go over the components of hypothesis testing, just talk about what it is, why it's here, and go over the basic elements of the notation, talk about some of these things like down here at the bottom as far as reject, fail to reject go, why that is, and then go over some basics here for a hypothesis test. So let's go back up here at the top and begin. So with the notation, we have this HO, and HO basically, I have to just, maybe I just write this out here. It's you have HO and or the null hypothesis. So this is the symbol here, null hypothesis. It really is H naught. So and it gets, and it's not N-O-T. It's not that. It's N. It's a little weird. N-A-U-G-H-T. And that's common in mathematics to use the naught. Trying to think of a couple of different examples here in mathematics. I think it's a left knot in using the Arabic symbol. Has a variety of different. So the knot is like kind of common, but it's not NOT like what you think it's pronounced. Basically initial or starting point. So when we're looking at the null hypothesis, that's the initial hypothesis, and it's denoted by H naught or HO, wherever you want to call it. It's all the same thing there. Now the other component to that is the research hypothesis here, or the alternative hypothesis, and that gets a variety of different notation to go along with it. I've seen H1, I've seen HA. For us, we'll go ahead and use HR instead, and for all purposes, that's my signature use on it. I think I've only seen it used once, and only because that I want to emphasize on the structure of it that HR stands for the research hypothesis, that we know that that's the quote from the researcher, or not the quote, but the intention of the researcher versus what they want to do with a claim. So the method here for this, here's outlined, since they are contradictory, and the reason is because they want to use a method here called proof by contradiction. So that has actual name in Greek. It's a well-known logical way to approach an argument. And the idea is assume the opposite, or assume not in that case. Like in that, I'm not saying N-A-U-G-H-T, but the N-O-T version of that, the complement idea. And proof by contradiction is pretty easy to do. Suppose that someone says, well, you know, we caught you in the act. Well, and then you would say, well, I have an alibi, therefore that would be impossible. You know, assuming, let's say that, you know, assume the opposite, you know, were the case. I did, for my master's degree, I did proof by contradiction. I think it was with, oh my goodness, I have to think back that long ago. Oh, it was proof by contradiction with the wow, I'm gonna probably not say this correctly. Um, Banach-Tarski's paradox, yeah, like that thing with um, using algebraic geometry, the conversion there from 2 to 3 dimensions, but I basically did the argument in 2 dimensions, but I assumed the opposite. I assumed not, and then went through and ran the argument, and there was implied a contradiction that it couldn't work in 2D versus that it worked, I'm sorry, not 2R versus 3R. But, you know, that was then and there. So, anyway, so this is all that we're doing here is basically outlining this thing called proof by contradiction. And it kind of like goes along with this idea that in the end, you're going to make a decision for one of the two. You're going to either reject or fail to reject the null hypothesis. So, why is that? You've got to take one perspective with it. Later, as I go through, I don't want to talk too long on this. I could talk about 20 minutes here on on this, talking about this theory and all that. I think it's just wonderful. But this basically outlines research, and I know like right now this is 2020. We're in quarantine. We're talking about the coronavirus right now, and people assembling together a vaccine will have to go through a process in order to be approved beyond reasonable doubt. And so when they see like the research list pump something through, it's not that simple. It's got to be proven legitimate. So it's a good thing. In fact, there's experts out there that even are components in pro-vaccine and think we shouldn't develop anything for the coronavirus in general. It would be lethal, nonetheless. So, but that's another story there. The idea is that you've got to make a choice there. Either take the perspective of the null hypothesis or the research hypothesis. So we'll anchor the null hypothesis in making a decision here that from the whole process we're going to assume is true. So assume true, but try to prove, yet prove not true. Same thing like if someone's on trial and what you basically have, they have a defense lawyer and then there's a prosecution that's from the district attorney's office, that their job is to make the choice. So the jury gathers all the evidence and they decide either guilty or not guilty. And that is because the person on trial is assumed to be innocent through the whole process, no matter what. So from day one, the jury is supposed to assume that person is innocent until proven guilty. And that's why in the decision at the end, the jury says either guilty or not guilty. They don't say, oh, they were assumed innocent and we've also again proved that they're innocent. It just doesn't work that way. If you assume that they're innocent, they are, until you try to prove otherwise. So even in our judicial system, we use the same sort of technique. And that outlines down here. So like basic symbols that go along with this for the null hypothesis, you have some sort of equality here. So outlining this general for HO, there's going to have either equals, less or equal to, greater or equal to, some sort of equality involved in that for the symbols used. But for the for the research hypothesis, we'll go with where is it here? Not equals, strictly less than, or strictly greater than for those choices for that, because it doesn't want to identify with that claim, and we'll talk about that in a little bit. So coming down here, basic rules for set up for a hypothesis test. I like, and this is a suggestion from the author of the book. I thought it was really good, that the null hypothesis must include an equal sign, and just go with that. Just go with like it is identifying with a claim. that it's equals. We just do that. Like, for example, the null let's say the null hypothesis, mu is equal to the number 50, 50 grams or something like that. We're just assuming that, that's, the case in dealing with equality. It identifies with that number. Part 2, one of the hypothesis must represent the claim being used. They actually both do for, so I think that's a little typo. One, they both do. Both hypotheses represent the claim there, absolutely. And then part 3 there, the hypothesis should be contradictory, absolutely. So HO versus HR, they both work against one another. And obviously from the researcher's point of view here, I'll even point this out. The researcher wants to prove, obviously, the research hypothesis, by all means what they're trying to do there. But we assume the opposite, contradictory to that, is the null hypothesis, and that identifies with the claim. And so we'll go through some different examples here, like this one here, like here in quotes, like, we wish to test a claim that, strictly more than 30% of the registered voters in a certain county voted primary election. Find the hypothesis, for this, all that. Pretty easy to do. Like, before I get in that next example there, you probably see at the bottom there about GPA. So we have the null hypothesis and the research hypothesis. The null hypothesis identifies with that number. So focusing on that 30%, we're saying that the population proportion is equal to 30%. But then from the researcher's point of view, we want to prove like what the following: either more than, less than, and then here it is, more than, strictly more than that number. So the researcher wants to prove it's strictly more than 30%. And that's just a setup for it before we go ahead and get started. So this is my little preliminary video on introducing some of the symbols here for a hypothesis test, going through the structure of it, talking about HO and HR, the null hypothesis versus the research hypothesis, assuming that they're both contradictory statements, using proof by contradiction in order to go through this whole step here. We talked about our judicial system, that is something very similar, if not exactly the same as that, and then reasons why we go through even a hypothesis test in general. All right, so that'll complete it here for the first video for section 9.1, elements of a hypothesis test.